Myself Pranali, I again welcome to you all in our course Database Management System, that is DBMS. This is our third video of unit number 1. In this video we cover the different views of data, data architecture, uh, data models in details. So let's start. View of data. Dear student, we all know that database is a collection of interrelated data and the set of program to access or maintain this data, right? So, uh, the but main purpose of your database management system is to create an abstract view of your database to a user. How we create a view of data or abstract view of data? That is using data abstraction, instances and schemas and data models. So we will see every points in detail. First is a data abstraction. To build or um, database designer is concerned with retrieve your data from the database easily, right? To perform this retrieval operation on data, database designer use a complex data structure in a coding or in a programming, right? But your user of your database system is not computer trained person. Therefore, it is necessity to hide the complex data structure or complexity of the database from the user. Hence, this hiding is becoming important factor for a non-trained person or user. This data abstraction is divided into three levels: physical level, logical level, and view level. As shown in the figure, this is the lowest level of data abstraction known as physical level. The middle level is a logical level, and the last higher level of abstraction is a view level. We will see every level in detail. So first is your external view. Note that the physical level is the lowest level of abstraction which describe how the data are actually stored. But at physical level, the complex low level data structures are in detail, but it hides the complex high level data structure. Then next is your logical level. The next higher level of abstraction, that is logical level, describe what data are stored in the database and the relationship among that data. The logical level describes the entire database in terms of small number of simpler structures. Then, therefore, at a logical level, database administrator who must decide what information keep in a database use the logical level of abstractions. Next is your view level. The highest level of abstraction describe only a part of entire database. Let's take one example. Whenever in a university database, your exam section department does not have an interest in your personal detail. Therefore, personal detail hide from the examination user of from the examination department from the university database. This is known as particular view level. Even though logical level uses a simpler structure, somewhat complexity remains at a logical level, but your view level is totally, all the complexity gets hide in a view level. Hence, the view level of abstraction exists to simplicity their interaction with the system. The system may provide a many view for the same database, right? As shown in the figure, this is view 1, view 2 up to view n. For the same database, there are n number of view you may create for a single dataset. So, first your external view. The highest or top level of the data abstraction we already see three level: view level, logical level and physical level. Your view level also named as external view, and it is the view level, external view. It is the highest or top level of data abstraction. Dear student, remember, in a view level or in an external view level, no knowledge of DBMS software, hardware or physical storage. At this level, the user which are not computer trained person, these are considered at the view level or external level. This level concern with the user. Each external schema describes the part of the database that a particular user is interested in and hides the rest of database from the user. We take one also earlier case example of university and examination department. In this case, the interested part of the database is only shown to that particular user of examination department. All other part of the same database is hide from that user. There can be n number of external view for the same database, right? For example, account department may be only interested in the student fee details. It would not be expected to have any interest in the personal information about the student. So only fee detail is showing, that is the abstract view of fee detail is shown to that department, account department, and other rest part of the same student is hide from that department. All the database user work on an external level of DBMS. So this is a total explanation for view level or external view. Then now conceptual view, that is logical level. This level is a between user level and physical storage view. There is only one conceptual view for a single database, right? For a view level, there are n number of view level maybe for a same database, but dear student, logical level is only one level for a single database. It hides the detail of physical storage structure. Okay, how data gets stored or where data gets stored is hide at this level. And for this level, it is only concentrate on describing the entities, data type, relationship, user operation and constraints. Let's take another example. Suppose in my university database there are n number of tables, right? You were in a view level, user are interested in a particular table, but at a conceptual level all the tables data types, relationship between amongst the all tables are show at a logical level, but where your tables get stored and how your table gets stored at it hide at this level. Next is internal view, or also named as physical level. It is the lowest level of data abstraction because it has the knowledge about software and hardware. At this level, it gives the information about the actual representation of the entire database. That is actual storage of the data on the disk in the form of record or blocks. It is close to the physical storage method. The internal view is the view, that is physical level, that tell us what data is stored in the database and how. At least the following aspects consider: storage allocation, access path are visible at a view physical level or internal level. The internal view does not deal with the physical devices directly. Remember that your physical view, that is internal view, does not deal with directly to the physical devices. Instead, it view a physical devices as a collection of physical pages and allocates the space in terms of logical pages. So these are the three level of abstractions: internal, physical level, lowest level of abstraction, conceptual, logical, deal with the modeling of the database, and external, that is view level, it the highest level of abstraction. So working of these three levels: first, presentation layer, Next, logical tier and data tier. So first your user sends a command, only he wants get totals. This is the requirement of your user. This is get sales total for total sales. This is a problem sent by your user or query. In our database management system, we said that this is a query. So query is sent at this view level. There are n number of view level are there. Then this query is get sent to the logical tier. It matches the database in the database, and he deal with the database physical data tier, find out the data from the storage and retrieve that data to a user. This is three level architecture for your database: presentation layer, logical tier and data tier. Again I repeat, at the top level of the application, it is a user interface. The main function of the interface is to translate the task and result to something the user can understand. Logical tier, this layer coordinate the application, processes, command, makes the logical decisions and evaluation and perform a calculation. It is also move the process of data between the two surrounding layer. Data tier. Data tier is totally based or depend upon the database and storage systems. Here the information is stored and retrieved from the database or file system. The information is the passed back to the logical tier for processing. Again processing is done at a logical tier, and then it eventually sent back to the user in terms of output. So this is level of DBMS architecture. User, n number of user, you can send a query from your laptop, your desktop machine or whatever from your mobile. Now external mapping is done with a one single conceptual schemas, that is logical level, and conceptual mapping is done using with the physical schemas, and physical schemas is dealt with a database, right? So at a lowest level of data abstraction is physical schemas, conceptual schemas and view level. Let's take one example, university database. Suppose this is an external schema view 1, external schema view 2. That is course info is a one view and student info is one view. But at conceptual schema is only one for one database. So your student info is also there, course info is also there with the column name and data type of that column, and how they are interrelated to each other is also shown in your conceptual schemas, right? And at a physical schema, relation stored at a unordered file, index or the first column of the student, where your data gets stored, the path of the data and the overall design of your database is stored at the physical schema. Done. For a external, see here, for a view 1, if one user is using view 1, he is only shows the part of database course info table, or the he is aware about only one view of a database, that is course info. Another view 2 is only having knowledge about student info. For a view 2, course info is hide. For a view 1, student info gets hide. This is known as view level of abstraction. Done. So dear student, in our view of data, first point is data abstraction. We cover data abstraction levels in details. Now second point is instances and schemas. Okay, so we already knows the types and variables in any programming language. Suppose in a C++ language there are variables and some data types, right? So similar to the any other programming language, your database, that is SQL or any database programming language, having the instances and schemas. So first logical schemas and physical schemas, and then we see instances. Dear student, a schema is known as a structure of your database. Okay, whenever you want to design any database, first step to build a structure for a database. This structure is known as schemas. Okay. Now there are two type of schemas, logical schemas and physical schemas. First is a logical schemas, means at a logical level how your database is look like, or design of your database at a logical level is known as logical schemas, and physical schema is the overall physical structure of your database. In a logical schemas, if we take an example, database consists of the information about set of customer and account in a bank and the relationship between them. Okay, so first table is for customer, second table is for account detail of that customer. Now the relationship among them and the separate tables or separate view of the data is shown in a logical schemas, but overall structure of full bank database is shown in a physical schemas. Now next point is instant. Now dear student, we already know that database is for managing, retrieving, updating the data from the database. So after every execution, suppose new customer is come to my bank, he wants to create his account in my bank. That time he gives the detail, I create a account for that customer. That time a new entry get placed in my database. So this is known as instance of that database. The actual content of the database at a particular time is known as instance. Okay. Now the physical, all of you getting the concept? Instances and schemas. Schemas is a structure. This is schemas is done at once only. Whenever you want to create a new database, you create a schema. First schema, that is a structure of your database. This is a one-time process. But your instances happen whenever you enter and you add new entry. That time a new instance is created for that time. You delete some entry, a new instance is get created. All of you getting point? That is, schema is a structure for your database. It is one time process at the time of creation of database. But instance is happen whenever a new operation get performed on your database. Dear student, but there is sometimes necessity to modify the schemas of the database without changing the logical schema. This is known as physical data independence. Means application depend upon the logical schemas. In general, the interface between the various level and component should be well defined so that changes in a some part do not seriously influences of other. This is done under the schema section. Means you design your database in such a manner that suppose I want to change one part of one logical schemas of your database, it does not affect the another logical schemas. This is known as physical data independence property. Now your next point is data models. So dear student, there are some type of data models named as relational model, entity relationship data model, object based data model, semi structured data model, network model, or hierarchical model. So we will see every data model and what is data model first of all in detail. So what is data model? So dear student, your data model is a collection tool to describe the data, data relationship, data semantics and data constraint for a database. So your data model provides the way to describe the database design properly or fully. Means Your data model consists of actual data, data relationship, the constraint of your own data in that particular database, and data semantic in one place. Okay, so there are first is your relational model. Relational model uses a collection of tables to represent both data and the relationship among those data. Each table has a multiple column and each column has a unique name. Table is also known as a relation. In a relational model is an example of record based model. Okay, so there are n number of tables also known as relation. In one table there are n number of column having unique name for that particular column. Then next is your entity relationship data model. This is for mainly for database design purpose. The entity relationship data model uses a collection of basic object called entity and the relationship among this object. An entity is a thing or object in a real world that is distinguishable from the other object. So entity is a real world thing we represent in a database. So this entity relationship data model mainly is for database design purpose. Next is your object based data model. Object oriented programming, especially Java, C++, C hash, becoming dominant software development methodology. This lead to development of an object oriented data model that can be seen extending ER model with a notation of encapsulation, methods, object entity. Object relationship data model combines the feature of object oriented data model and relational data model in one place. Okay, so object oriented data models enhanced version of entity relationship data model. In entity relationship data model, data abstraction, encapsulation, these terms are get involved. That time that model is known as object based data model. Next is your semi-structured data model. The semi-structured data model permits the specification of data where individual data item of the same type may have different set of attributes. Mainly, extensible markup language, that is XML, is widely used to represent the semi-structured data. So this is your relational model. As we discuss, all the data is stored in a various table. Example, that is as shown in figure. Suppose instructor is one table. We also call instructor is one schema. Schema means structure. This ID, name, department name, salary are the columns for this schemas or for this table. This is a instructor table, department table. There are multiple tables in one database. So first table is an instructor table, second is your department table. Whenever you use this type of structure, that time it is known as relational data model. Next, for storing or dear student, see here we covering a different type of data model. First is your relational data model. Your relational data model consists of different type of table. Okay. Now in a table there are multiple columns. Now consider this data is not in the first step. If I want to create this table, that time first I draw a simpler structure for a instructor table using data definition language, that is DDL. So dear student, DDL is specific for creating a database schemas. We already covered the difference between schemas and instances. So your DDL, data definition language, is a specification notation for defining the database schemas. Now, suppose I want to create this table in my relational data model. First, I use a DDL command, create table instructor having 4 columns, right? ID, name, department name and salary. So, using this DDL command, I create a schema. Schema, this is logical schema, right? because I only create one table. I only create an instructor table, one logical schema. Suppose I uh, define or declare all the table in the database, and I also shows the relationship between all the table. That time it is physical schema for that database. Okay, so DDL compiler generate a set of tables template stored in a data dictionary. Then data dictionary contains a metadata. Metadata means data about data, means your physical schema. So database schemas, all the integrity constraint, authorization, who can see your database, all the relationship between all the tables is known as physical schema, and this physical schema is stored in your data dictionary. Done? Next, your data manipulation language, that is DML. So dear student, languages for accessing and manipulating the data organized by appropriate data model using DML command. Dear student, again we come here. So first, using DDL command, data definition language, we create a structure, but these entries 2222, Einstein, physics and salary, all these entries are created using data manipulation language, that is DML. So accessing and manipulating a data from a particular table or from a particular schemas using DML. Then, so two classes of language, that is pure and commercial, used for providing a properties about a computational power and for optimizational relational algebra, tuple relation calculus, domain relation calculus. These are the pure languages for your database. And commercial, SQL is most widely used commercial language for your database. Then we see every relational algebra and SQL in detail in a second unit. Now SQL. This is the introductory part of your SQL language. The most widely used commercial language is known as SQL language. Full form of SQL is structural query language. SQL is not a tuning machine equivalent language. SQL is not a tuning, it is to be able to compute a complex function. SQL is usually embedded in a some high level language. Okay, so application program generally access a database through one level, that is language extension to allow a embedded SQL, application program interface, that is ODBC, JDBC, which allows the SQL to query to send to a database. So dear student, for a relational model, we use a DDL, DML or SQL commercial language. So next, your object relation data model. So relational model, flat atomic value, but object relation model is a extend the relational data model by including the object orientation and construct to deal with the added a data type, allows the attribute of a tuple to have a complex type including non-atomic values such as nested relations. This is object relational data. In a object relational data model, the object oriented concept get involved in an entity relationship model. There are also semi structured data model defined by the WWW consortium W3C, originally intended as a document markup language, not a database language. It is the ability to specify new tags to create a nested stack. XML is a great way to exchange data, not just a document. XML has becoming the basic for all new generation data interchanges format. A wide variety of tool is get available for parsing, browsing and querying the XML document. So these are comes under the semi-structured data model. Now your one part is your database design, which is comes under entity relationship model. The process of designing the general structure of database, there are two types, logical design and physical design. Deciding on the database schemas, database design required that we find a good collection of relation schemas Business decision, what attribute should be recorded in the business. Computer science decision, what relation schema should we have and how should the attribute to be distributed among the various relational schemas. Now second is your physical design. So we already covered there is a one logical schema and physical schema. So logical design is related to what relation schema should we have taken to design a database, and in a physical design decide on the physical layout of all the tables or relation in one place, that is deciding the physical layout of the database. So using data normalization and entity relationship model, we design a database. We will see how in the next part of this video lecture series. Now, database engine. To detail understanding of database architecture, these three terms are very important. So before moving to the database architecture, we see these three terms in detail, that is store manager, query processing and transaction manager. Okay. So first is your store manager, that is store management. So dear student, first is your storage manager. Storage manager is a component of a database system that provide the interface between low level data stored in the database and the application programs and the query submitted to the system. How? The storage manager is responsible for the interaction with the file manager. We already covered in the introductory part whenever we uses the DBMS, but there exists a file system in your computer. So the interaction between file systems, query, different type of queries submitted to the system, the store manager works. The raw data are stored on the disk using file system provided by the operating system, right? Whenever we buy a new computer, we install one operating system in our computer, there is automatically file system is exist. Now whenever we uses a database management system, it is needed to coordinate between file system and database management system. So storage management is a interface between these two. The storage manager translates the various DML statement into low-level file system commands. Okay, so storage manager component include authorization, integrity manager, transaction manager, file manager, and buffer manager. So, dear students, they are dealing with the data files which stored data in a data self itself, data dictionary which stores the metadata about the structure of the database in a particular schemas of the database, indices which is can provide a fast access to data item. Okay, so dear student, your storage manager is responsible for interaction with the OS file manager, efficient storing, retrieving and updating the data which are related to the DML commands. Okay, now next is your query processing. The query processing commands includes DDL interpreter and DML compiler. So consider DDL interpreter. DDL is for creating a schemas, right, which interpret the DDL statement and record the definition in the data dictionary. Who? Query processing. First, DDL interpreter. Second, DML compiler, means which translate the DML statement, that is query language, into the evaluation plan. So as shown in figure, this is a evaluation. So this is query. Query get parser to the parser and translator. This on it take a decision. Parser or translator take a decision in relational algebra expression. Optimizer is there. Optimizer gives a execution plan using statistic about the data, and this execution plan is given to the evaluation engine, and evaluation engine retrieve the data from the database and gives as a query output. So dear student, you only remember in a query processing, parsing and translation is there, optimization is there, and evaluation is there. Now, next is your query processing, alternative way of evaluating a given query, that is equivalent to expression, different algorithm for each operations. Cost difference between a good and bad way of evaluating a query can be enormous, depending upon the application. Need to be estimate the cost of operation depend upon critically on statistical information about the relation which the database must maintain. Need to estimate the statistic of the intermediate result to compute the cost of complex expression. Now next is your transaction management. Why transaction management is needed? Whenever what if the system get fail? What if more than one user is concurrently updating on the same data? That time transaction management is needed. So transaction is a collection of operations that perform on a single logical function in a database, right? And transaction management component ensures that database remains in a consistent, that is in a correct state, if despite system failure, that is power failure or operating system crashes and transaction failure. In all the cases your database must be remain in a consistent state. This is the function of transaction management component. There is a concurrency control manager. This concurrency control manager control the interaction among the concurrent transaction to ensure the consistency of the database. Now dear student, these three are the very main part of your database architecture: storage management, query processing and transaction management. Now this is a important concept, that is database user. So database user and user interface. There are four type of database user: Navy user, application programmer, sophisticated user and specialized user. We will see one by one. That is your Navy user. So dear student, naive users are the unsophisticated user who interact with the system by invoking one of the application program that have been written previously. For example, let's take an example of clerk. Clerk in the university who needs to add a new instructor to department A. Invoke the program new hire, right? The program ask the clerk for the name of the new instructor, that is ID, name of the department and salary. He enters some detail about new entry and add that new entry to the application interface. So first naive user is a tailor's agent or web user who uses the application interface, and this application interface furthermore connect to the database, right? Next is your application programmer. These application programmer are the computer professionals who write application program. Suppose let's take one example. Suppose a clerk, a university clerk is a naive user, right? Suppose this university clerk required the list of student according to the postal code. That time he tells to the application programmer to write a new application program to sort out this student according to the postal code. So who writes the program? Application programmer, right? So application programmers are the computer specialized professionals who write an application program. Application program can choose from many tools to develop the interface. Now sophisticated user. Next is your sophisticated user or analyst. These are the interact with the system without writing the program, right? They are uses a system without writing a program. So they uses a query language or uses a tool such as data analysis software This is known, that type of user is known as sophisticated user. Next is your specialized user, known as database administrator. This specialized user are a sophisticated user who write a specification database application and do not fit into traditional data processing framework. So this is known as database administrator. Database administrator uses a data administration tools to schema definition, schemas and physical organization modification, granting the authorization for the data access, who they create a view for the users. These are the working of your database administrator. So this is your different type of user. Now we are finally come to the diagram, that is database system architecture. So first of all, listen carefully. These are the users: naive user, application program, sophisticated user, and last is your database administrator. So this uses, we already discussed this first part, that is there are type of user for your database. Naive user uses the application interface. Application programmer are the computer writes a application program to access the database, and sophisticated user uses the database using query tools, and administrator are uses administrator tools. Now second part, the request is given to a query processor. Now this query processor uses a DDL interpreter. DDL interpreter is for creating a schemas, applying a constraint, or give a particular view to this data. This is all comes under the administrator. So DDL interpreter. Now DML query is for what? Whenever sophisticated user uses a query tool and send a DML queries, that time DML queries part of query processor are work, and in these DML queries, DML compiler, organizer, evaluation, all these are we are discussed. This gets a query evaluation and send back a result to your user. Okay, now next is application program. In terms of application program, their need of compiler and linker. So this is all comes under the query processor. Now second part is a storage manager. So in this, buffer manager, file manager, authorization and integrity manager, and transaction manager are gets comes. We already discussed all the function of this storage manager, and at last there is a data disk storage, that is your database, and in this database data, indices, data dictionary and statistical data it gets stored. So this is a overall database system architecture. Hope all of you are getting all this point clearly. So dear student, for today we stop here with a concept of view of data. There are different data models, and at last the database system architecture. So dear student, for today we stop here with a new knowledge of data models, uh, database architecture and view of data. In next lecture, we are moving toward the one of the important data model, that is entity relationship data model. Okay, so thank you for your patient listening.